Hello, Craig O'Neill. Thank you for being with us today.
Matt, it's great to be here, and man, I'm excited for what's coming up this year, and appreciate to join you early in this year.
Oh man, we are super stoked about the conference. We're less than 80 days away. A lot of great things in store. So I'm really happy about it. Again, let me just introduce myself. My name is Matthew Gobert. I'm the president of 4C Marketplace and Conference. Our conference for 2023 will take place in April.
Wow.
4th through the 7th, man, right around the corner. It's
up.
right around the corner, brother. So I'm excited, man. Just for those who don't know, 4C stands for Connect, Collaborate, Contribute to Compliance. So today we're, again, with Mr. Craig O'Neill of Teledyne FLIR.
That's right.
Tell us about the company. And, I know you guys were separate at one time, and now you're together. Tell us a little bit about that.
Very good, Matt. You forgot to say the new president of the 4C conference. So I'm excited to join you on this new run here, and it's been great working with the 4C team for over 10 years now at FLIR, now Teledyne FLIR. And to continue this partnership, collaborate with you guys. One of the C's there in the motto. Moving from the letters that we started with at the LBT conference over 10 years ago to the 4C. So this has been great, and I'm excited for this year. So Teledyne FLIR is a company. Well, Teledyne is a company that is a large company that produces sensing solutions of a variety. Everything from detectors on satellite. Most people don't know. We've got I think it was a handful of different technologies on the rover on Mars.
Wow.
We actually have, we produced, I believe, 3 or 4 of the detectors that are in the telescope, that is in the space telescope at Teledyne. So it's a broad company. And in 2021, they acquired FLIR and announced that acquirement, and it's been a great transition. So now we're really, as an organization within Teledyne, we're really kind of running on our own to some degree, right? We have a lot of opportunities being able to collaborate with Teledyne. As an example, there are multiple other Teledyne divisions that are joining us at the 4C.
Awesome.
One of them is
Excellent.
one of them's going to join us in the booth. Another one is going to actually be another exhibitor there. So we have our Advanced Pollution Instrumentation Group, our Gas and Flame Detection Group at Teledyne, which are now our sister companies. So we're excited to do that. But FLIR, as that, we really haven't changed, right? At FLIR, they've kind of let us run and ensure that we run on our own and continue the success that we had at FLIR. And so many people may realize or remember FLIR. We've been the leaders in optical gas imaging since we came out with the very first commercial optical gas imaging camera in 2005. And so been really in this compliance world in one of the C's here. And we've been able to help the industry comply with various regulations, and not just regulations, right? Comply with their internal emissions metrics or maybe their ESG goals. And so at FLIR, we really focus more on the infrared side. For the most part, about 60% of our business at Teledyne FLIR is based on infrared. 40% of our business is based on other aspects of the business. We make acoustic imagers, which really is an infrared. We're still utilizing that electromagnetic spectrum, right? Utilizing different wavelengths. But generally speaking, we make infrared technologies. One of the previous to the acquisition, the motto of FLIR was the sixth sense, right? You have that sixth sense, you always get that feeling. Wouldn't it be great if you could see that feeling? Right, you get that feeling that something bad's happening. You get that feeling that that there's something wrong or there's something behind you. Wouldn't it be great if you had a technology that could see that mountain lion coming up on you?
Definitely.
You get that feeling that something's bad's happened on a well pad. Wouldn't it be great if you had a technology that allowed you to physically see that sixth sense of what's happening on that well pad? And that's what we're excited about. That's what we've been doing for now 17 years, and we're super excited about the future of optical gas imaging and helping support the conference.
Well, first of all, I want to thank you for being a platinum sponsor. We really appreciate your support. You have been a mainstay for the conference for the last several years, sixth inception, really. So we really appreciate that. And then a little bit of the history that you brought up. I mean, you guys bring a whole different viewpoint of being a worldwide. If you're on a telescope and satellites, you're definitely a worldwide company around everything. But being a service provider for many years, when you guys came on the scene, I mean, FLIR changed the game.
Oh, yeah.
I mean, it really took what we were doing for years and just put a dynamic spin on it. So, I mean, you guys are truly game changers in this. And I'm extremely excited for you to be on our first podcast here. But I have a few questions for you, if you don't mind, if I kind of start firing at you a little bit there. Okay, what is optical gas imaging for those who don't really know what's going on here?
Yeah, sometimes I get a little bit too deep, and I've been doing this since the inception, right? I've been directly involved with optical gas imaging since 2005. It's very simple. You may hear it termed OGI, which is it's utilizing an infrared technology. In other words, we're utilizing the gases that we're looking for.
Okay.
And we're utilizing an infrared waveband, and we're filtering specially made cameras, right? We have really expensive to make, expensive to sell, and most of our customers know that. But we have these high-end cameras. It's just an infrared camera that is specially engineered so that it can visually detect the gas that it's manufactured for. So one unique thing is we often get the questions, well, it's an optical gas imager, so it just sees out all gases, right?
That's what some assumes, yes.
The answer is no. We actually have 5 different cameras in our cooled portfolio.
Okay.
One is made specifically for hydrocarbons and VOCs because hydrocarbons and VOCs, they absorb energy at a very common infrared spectrum waveband, right?
Okay.
I won't get too techie into this, but it's very common. It's around the 3.3 micron range and do that. Well, carbon dioxide is a little bit different. It has a different waveband or a little bit different absorption spectra. Carbon monoxide, we make a refrigerant camera that sees hydrofluorocarbons and refrigerants. But our second largest selling camera is one for sulfur hexafluoride or SF6. Which is a camera that is often used in the electric utility industry for SF6 detection, which is also something that is being looked at and monitored by the EPA.
So from an infrared technology standpoint, you guys are covering the spectrum, right?
Yeah.
Not only oil and gas, but you guys kind of service every industry from that aspect of it.
So most people think of infrared as the same thing that maybe the military uses or that you would use in a day-to-day camera that you put on your phone. We manufacture those as well, right? We manufacture a wide variety. Some of those go down to a few $100s for a camera that may fit on your phone and just be kind of a tradesman type of tool.
Okay.
These are very, very different in that. And that has to do with the different types of technology or the types of materials that we make the detectors out of. Most of those lower cost infrared cameras, which again, they're very valuable. They measure temperature. They allow you to look for insulation voids in your house, electrical issues, mechanical issues in a plant or an industrial facility, which the optical gas imaging cameras, because they're infrared, they measure temperature as well. They actually give you the capability to do multiple applications. You can actually measure temperature and look for electrical, mechanical, and other challenges, or you can confirm a delta T if necessary within the optical gas imaging world. So again, very similar technology, and the good thing is FLIR is in all of it. So it's a fun technology to be a part of.
So were you guys really big when COVID was at its highest point? Did they use your technology from an infrared standpoint?
Not as big as we'd like to have been, right? So, I think that 2 things happened at the same time, right? One, COVID hit, and the other one was called supply chain.
I agree.
Those 2 things hit at the same time. Fortunately for us, as somebody, that is advanced in temperature screening or temperature measurement, what's unique is you have technology that measures the surface. So I don't see through a body into my body temperature. I don't see through a wall. I don't see through a tank. I don't see through a furnace. I actually see the surface temperature. So what we can do is measure the surface temperature of a human being. And we call it an elevated skin temperature, not body temperature. We're not truly measuring your body temperature. We're measuring your skin. But the best place to measure your skin is your tear duct.
Interesting.
that is, either your tear duct or directly through your inner ear. Those are the best places to measure your actual internal temperature without intrusively getting into a person with a thermometer through your mouth or some other way to do that. So when the COVID thing hit, we had some very, very high end things, and we had a pretty successful our numbers will show that if you were to look at our annual reports. But to be honest with you, we also ran into supply chain issues. But it wasn't, people looked at that. What was interesting for me as somebody that's always kind of been in the oil and gas or the electric utility, more of the industrial space, we were all hands on deck for everything you need. I was talking to banks on a daily basis or talking to corporate offices of oil and gas companies that wanted to get maybe their corporate campus up and running, but they needed to ensure that to do that, we want everybody that walks in the door to be healthy. We want them to not infect anybody else, and we want to ensure that we can all be productive if we were to do this. So, FLIR was very unique in the sense that we were able to provide that non-contact, non-intrusive way to do that, but we also had the history of infrared and understanding the real and true way to do that technically.
I think that's amazing. I mean, the versatility of the camera and your technology. Just kind of jump back in on this a little bit. If you don't mind, we talked a little bit about how long the camera's been around. We talked a little bit about some of the basic uses. What is the difference between a cooled and uncooled camera? I know a lot of people don't really, they hear the terminologies, but really don't understand the differences. Can you elaborate a little bit on that for us?
Yeah, the main difference between a cooled and uncooled is the material, as I mentioned, the material that they make the detector out of, right? So there are materials that need to be cooled to, very cryogenic almost temperatures so that they can operate, they can have a ability to produce an image and actually run. And those are called cooled detectors. As an example, the cameras that we use in the oil and gas industry for hydrocarbons, it's an INSBE or indium antimonide detector. Whereas an uncooled camera, you just turn it on and only thing that it's waiting on are the electronics of the actual camera, not on the detector. So if you've ever used an optical gas imaging camera that is cooled, when you hit go, it does take 7, 8, 9 minutes to actually turn on because the camera is not warm. It sounds like it's warming up, but instead what you hear is a little thermoelectric cooler that's cooling the camera down to cryogenic temperatures. And so when you do that, it does take a little bit of time, but that also means that camera is going to be super, super sensitive. And the other big difference is almost all uncooled detectors operate in a different wave band. As I mentioned, hydrocarbons and VOCs have a commonality or a functional absorption range around 3.3 micron. But there are specific gases that may have multiple absorption ranges, like methane. Methane absorbs energy at right around a 3.3, but it also absorbs energy at around 7.7. So most long wave or uncooled cameras are usually have the capabilities to work from 7 to 12 micron. So now you can take a uncooled camera, put a specialized filter either in the camera. We put ours on the actual lens itself. So it's a very versatile camera. So I can actually take a lens off that can see methane and put a lens on that can see ethylene. And so we really have that. But what's unique is that you have to have that cooled camera around that 3.3, that mid-wave camera to be able to see, if you will, I can't say all hydrocarbons, but almost all hydrocarbons that are really the functional side of hydrocarbons. You really have to have that cooled mid-wave camera. But the long-wave cameras, the uncooled cameras, you have a lot more flexibility. The other thing is price, right? You have a camera that needs a lot more parts in there to be able to cool it, to be able to run it. You've got the Sterling electric cooler that's cooling the camera down. All of those things, as well as the detector itself, are much, much more expensive than just a standard everyday uncooled detector.
So let me ask. So if we go to it from a standpoint of being in the service industry for the last 30 years or so, the camera came on the scene, phenomenal tool, really changed the game, as we said earlier. use both in upstream, midstream, as well as the refining sector.
Yep.
If I'm a camera operator, I see the camera and I'm like, hey, man, this is a great tool.
Yeah.
I'm in the environmental department. I need this technology to help me out, whether I'm looking at tanks or different, looking for where there may be a release in the field. I'm in a maintenance group. I mean, this camera can be used in both departments or throughout the whole facility. It's not just a tool for an environmental group. Can you elaborate? I mean, what other uses in every department of the plant, facility, who all can use this camera?
Yeah, so if you think about it, we came out with this technology in 2005. What's unique is if I pull up our actual the day we launched this, right? Our press release or our wire release. There are quotations from the EPA who worked with us pre-release in the engineering of this as a tool that they would expect to see helping their efforts for compliance in the future. So, while it's not directly tied to our business, there is some side of compliance that is tied to optical gas imaging. So in 2005, we had a camera that came out. There were no regulations at all, really, until December of 2008 that even mentioned optical gas imaging. Another kind of fun fact is the term, we used to call the camera the gas finder.
I remember that.
The original camera was called the gas finder. The term optical gas imaging was really introduced in the alternative work practice documentation of 2008. And so when that was actually introduced, it kind of took a different name as a technology more for the industry. But if you look at from 05 to 08, there really wasn't anything driving that. And we sold a number of cameras to a number of people in both the upstream and the downstream. In 2008, the downstream market began to recognize the tool as something that could benefit them as far as compliance go. But the downstream was also more regulated in compliance since the mid-'80s in the service companies, as you mentioned, that maybe use a TVA or a sniffer. And so if you were to fast forward to 2015, when Quad OA was originally written, that's where it really kind of changed the breadth of compliance of our technology. But if you think about it, now we're going 10 years, 11 years, from 2005 to 15, and we've sold, we've been able to support a large swath of the upstream market in that 10 years before we were even part of compliance as it relates to the technology. I remember when the camera first came out, we were only focused on the refineries. At that time, I was a regional sales guy. I handled the northern half of Texas, Oklahoma, and some other areas, or just into New Mexico. I had another counterpart that handled all of the Gulf shores and the refineries. And they started looking, going, this upstream market is embracing the technology more than the downstream market. And some of that was the downstream market, even today, kind of was handcuffed into a older technology that maybe not quite as efficient, according to the people that I speak to that have been doing this for a lot longer than myself. And so they do that. But when you're using the camera, they realized, you know what, I can keep that gas in the line and I can save a lot of money. It's not just compliance. And while I'm there, especially on a refinery, they can do a lot of other things. They can do anything electrical. Right? If you think about it, anything that has electricity running through it within a facility, especially in a refinery, it has a potential of failure and a potential of going down. You can use it for that. You can actually use the camera for anything mechanical, any pump, any motor that could potentially have friction that could cause that pump or motor to fail. The camera could help diagnose that over time. Another thing that we saw was you saw the environmental teams maybe get a camera, but then you saw the operations teams go, what is that?
Exactly.
And they were saying, you know what, when we do our turnarounds, it would be great to have a camera that we can use at our discretion before we flip the switch, if you will, right? To make sure that we are operating and we don't have emissions, we don't have leaks, and we can use a camera to do our inspections very easily on those turnarounds. So there's a huge, and this is just some of those applications that we kind of really were able to get into. Other ones are like tank levels, right? You can use any infrared camera to actually look at a level of the tank, the sludge level, the actual level. You can actually see where the water leg and the product leg and the water leg and the different legs within a tank. So you can actually have a production asset, a production capabilities with the camera. So a lot of different applications just to scratch the surface.
So you're looking at actually killing multiple birds with one stone. I mean, environmental, safety, as well as production.
Correct.
And operations.
And maintenance, yeah.
And
yeah,
maintenance.
MRO.
So, you're
Correct.
looking at a wide usage for the camera.
Yeah.
And I remember, back in, the cameras were a lot larger when they first came out. They used to have the recording separate.
Yep.
And now you've transformed where you have it all in one hand now. You
Yeah.
can have a single operator if need be. I mean, tremendous what you guys done from a technology standpoint.
Yeah, at FLIR, again, pre to the Teledyne, 3 of our pillars were enhancing productivity for our customer base, saving lives, because we have a huge public safety, police and
Yes.
fire, saving lives, but also protecting the environment. And what I love is with my technology, I get to say I do all 3 of those. Right?
That's awesome.
One camera stepping out into one facility can do all 3 of the pillars of our organization. Not to mention to be that sixth sense, and allow you to see really anything you need.
We're going to kind of jump into the 2023 into 2022, beginning of 2023. The whole buzz is about Appendix K right now. That's kind of what's on everybody's tongue. When was Appendix K introduced?
So Appendix K was introduced, there's different levels of Appendix K.
Okay.
Appendix K was originally introduced and brought out in the 2015 Quad O-A regulations that
Yes, sir.
began to introduce optical gas imaging into upstream. Not only did it introduce, for the first time, they actually defined a best system of emissions reduction, or a BSER, for that regulation.
Game changer, total game changer there.
And they said, you know what, optical gas imaging, I'm not going to be bashful. It was good for us. but there are customers that said, finally, we can use this technology that is more efficient, that's easy, that upon getting a trained operator, that's easier to use, and finally we can use this technology that allows us to do things better. And so that was first introduced, but it was, from my understanding, again, I wasn't involved in this, but from my understanding, it didn't quite get completed and finished. There was a technical support document tied to Appendix K in 2015. Okay. And then you fast forward to the current regulations that are under review. Some people may call them Quad O-BC. They are tied into Quad O-A revisions as well. That's where Appendix K was truly introduced as a determination of how to use an optical gas imaging camera. That would have been originally introduced, I believe, in November of 2021. And then the re-release, the second revision, if you will, of Appendix K through the Quad O-ABC regulations was in November of 2022. And right now they're currently under review with, I believe, the comment period is still underway. I think it's mid to early February.
Yes, sir.
I don't remember the exact date. So and what is different about Appendix K is that for the first time, they're really kind of saying how you need to do something. Most of the time, they haven't really said, they said, you know what, we're going to define the technology and allow the technology providers to make the technology to meet the goals of a regulations. Method 21 back in the day, there's not as much determination of how each individual person has to be trained, how they have to potentially, hold the sniffer, how long to look at it, at each individual joint, and how to ensure that gets done properly. They kind of trust that we're training them, where we know the technology can do the job, right? That's part of the Appendix K or part of any of this. And then we're going to train these operators, and we're going to trust that they can do. And that's one of the unique things about Appendix K is that we have no problem there with the aspect of Appendix K saying this is what the technology needs to do. Quad O-A did that.
Yes, correct.
They provided the, if you will, the box, right? This is the box I need to work in for the technology. What is unique about Appendix K is the way that they're defining how somebody has to do it on a daily basis, and how they have to have a daily quality assurance, or they have to be trained. And that's something that we're looking into right now, and finding the best way to support the industry and the market with respect to that, to ensure that the operators that need to comply with these regulations can do it efficiently and effectively.
No, that's awesome, man. Again, I'm with Craig O'Neill of Teledyne FLIR. First episode of Spilling the Tea with 4C.
That's right.
So we're super excited, man.
I was expecting a cup of tea here, with the little sugar cubes and maybe some crumpets here.
Well, the first one, we're on a budget on the first podcast, so we might get that next time around, man. But we're having a great conversation so far. Again, appreciate you being a platinum sponsor for the conference, which will be held April 4th through 7th of 2023 in Austin, Texas, at the Hilton downtown. We're going to go. We had a few people send in some questions for us, so we're going to shoot some questions out from the industry here. Does Appendix K have a dwell time?
A dwell time, yes. There is a defined dwell time. So what is unique is let me maybe just start. What is dwell time?
That'd be
dwell
great.
time
Yes,
is how long that you would need to look at a component or look at a piece of equipment to ensure that you're inspecting it properly, right? I think that a lot of the clientele at the 4C as well as the clientele at FLIR may be able to correlate to let's say deer hunting or maybe bird watching if you want to go a little bit less. When you get out in the woods and you're looking for something, you don't just sit there and put your head on a swivel. You look at little areas and look for a change in a tree moving or something happening. And that's what dwell time is, right? You look at a camera, you need to look at a specific area or a component for a certain amount of time to ensure that you can inspect it properly. The original dwell time in the 2021 Appendix K, the original Appendix K, I believe was right around 5 seconds per component that you would look at. What is unique is that they were very, I think the EPA was very fair. And changing the dwell time and lowering it down to 2 seconds per component. In other words, when I look at each thing, I stare at something for 1, 2, 1, 2. But what is unique is that if there are multiple components within one field of view, is the way that they have defined that dwell time. So dwell time is not just 2 seconds per look, right? You have to try to figure out how many components are in a field of view, and then you have to multiply that dwell time by 2 or utilize a table that the EPA provides. And it can limit what you do because when you use the camera, there's often multiple flanges or multiple pipe fittings or something like that. And so that's where there is, most of the customers that I talk to, of our customers, that's where some of the question mark is on the dwell time. I think most everybody agrees that a 2 second is appropriate for that. But the multiple components, I was asked one time giving a speech to a bunch of people and said, when you have multiple components, like how can you define like the way a camera works? So I'm looking out at the crowd of people and I said, well, let me just say it like this. There are 50 people in this crowd, right? And then if I'm going to ask you if your initials are CO, right? Or MG, I want you to raise your hand. Okay, I'm looking at 50 people in a crowd, and in a second I clap my hands, I want that to happen. So if I clap my hands and 3 hands go up, I don't have to look at each individual person for 2 seconds to ensure that I can see that there are 3 hands up, right? And so when you look at a scene and the way an optical gas imaging camera works, you can literally look at a scene and almost get that dwell time on a scene basis. And again, doing that again, I maybe I need to multiply it by 3 or 4, but maybe not by 5 or 6, and limit what I'm doing because of the way it would work. Just in a crowd, whose hands are up, and I can do it in 2 seconds. I could probably tell you how many hands went up in 50 people, without having to stare at each individual person to see whether their hand went up.
No, that's phenomenal. I think have another question come in for us. What is the importance of wind? And what are the regulatory requirements for wind speed? Yeah.
And so, wind is important. One, to have a little bit of wind is okay, right? It's actually preferred, right? Because if you don't have a little bit of wind, sometimes with a camera, because again, we're seeing emissions. Imagine if you if you have a fire, and sometimes when there's not a lot of wind, that smoke just kind of goes there and just pools around the fire. It gets a little harder to see with our cameras, maybe, with a little bit, but you're almost always going to have, when I say a little bit, I mean like a half to a 1 mile an hour wind. Okay. You just want something that causes that emission to move. It causes the gas to move. But there is a, law of diminishing returns, right? At some point, the wind might be too much in causing a leak to be blown out, right? What causes a candle to blow out whenever it's your birthday? Wind, right? You're producing wind and causing that flame to blow out. And so there may be that. So within Appendix K, and again, this is where we did this with the previous Quad OA regulation, where we developed an operating envelope. It was the first real operating envelope that was produced. It's the only one to this day that, to my knowledge, that is on a public domain website. Just go to FLIR.com/OGI, and you can download our NPL report. And what we did is we do the testing for the customers. We'll go out there and at different delta T's, different changes in temperature, and at different distances, we will say how well this camera can see at different wind speeds. So an operator can go on their site and take an anemometer, check the wind speed, and say, okay, I've got a 15 mile an hour wind. I know that I can't get more than, let's just say, 15 meters away. But I have a 10 mile an hour wind. I can get up to 25 meters away. So we provided this envelope to do that so that the operators don't have to do this on a daily basis.
Can you repeat that again? Where can we find that?
It's on our website. If you go to FLIR.com/OGI, there's a bunch of stuff there. That's our full optical gas imaging webpage. But down there we have both our certificate for Quad OA. We don't have a certificate for Appendix K yet because it's not finalized and we don't want to go do testing on it and then they change the rule. But a certificate for Quad OA, as well as what's defined as an NPL report. That's the company, the third-party company we used to do all of this testing. And what we did is we made an abbreviated summary of that report that they did. We made it public so people could do this. There are other ways to do it, and some people like to do it. Some service companies, as well as some operators, may choose to do this on site.
Okay.
I can take like a little camping propane tank and put a little valve on it to make it leak and be able to measure that leak to equal whatever it is that I need to inspect for that regulation. So I can set a propane tank and say it needs to be 5 grams per hour, or whatever number that is. And then I can say, all right, in today's environment or the environment that I'm at this site right now, how far away can I get? And then I know that parameter. And that's in the alternative work practice. Right? So when you look more downstream, that type of stuff, the people that have been a little bit more progressive in utilizing optical gas imaging in lieu of a Method 21 technology have been doing this daily instrument operating envelope check for, they've been doing this for a long time. I've known some customers that have been doing it for a considerable amount of time because they feel that optical gas imaging provides them such better efficiency, and they're going to save time and money when they can actually inspect things faster, 9-10 times faster.
No, that's a great point. I see the Gulf Coast is really representing here with some great questions. Let me hit another one at you right quick. Does Appendix K apply to all portions of the oil and gas industry?
So originally, that's a question that recently changed, or an answer that recently changed. Originally, Appendix K only applied to upstream and downstream, right? And so it does that. Well, there is precedence that both downstream has a regulation already in place. So you can't write an appendix to make it apply to something that's already in place. Okay. Again, I am not a lawyer. I'm not this, so I'm just saying what I've been told and the way I understand this. So you can't apply that to things that have already in place. So it would not apply because you have the alternative work practice. In upstream, you actually have Quad OA that's already in place, and that already has parameters of how you can do this. The one big gap in Quad OA is that they did not address the leaking components from existing components as of September 2015. Anything that was already in place was not addressed. And so Appendix K would not apply to those components that would fall under Quad OA because there already is precedent set for that regulation. Again, that's the way I understand it. specifically, and the main addition in the regulations that are being written today is for the natural gas processing plants.
Okay.
Those are directly tied to Appendix K, but the way Appendix K is written is that as they begin to advance, improve regulations moving forward, they now have a determination of how to use this technology to point to at any future regulations. So you mentioned down in the Gulf Coast, I would kind of expect some potential, acceptance of such a great technology and regulatory framework, because now they have a way to actually define how somebody uses it and point to reference that.
Okay. Man, I really pointing again to represent. Neither one of us are lawyers. Leave that to guys much smarter than both of us probably there. How often, another question comes in for us here. It says, how often must a gas plant monitor with OGI to meet the current regulations?
Well, that's a longer answer than I'm going to be able to get into today, right? That is very dependent on a number of things. One of those is there is a table and a matrix in the regulations today.
Okay.
And this is also dependent on the 4C compliance. Let's keep in mind it's easier to talk about the EPA, but there's also compliance on statewide. TCEQ may be different than the EPA, may be different than Colorado Reg 7, may be different than New Mexico, and so on and so forth. So this is Appendix K is only federal, right? So
Yes.
That is what it points to. There are different time frame regulations, in particular upstream. A tank battery or a well pad may need to be inspected on a quarterly basis, whereas something else may need to be inspected on a semi-annually basis. And so with Appendix K, or really with the inspections or the regulations themselves, there is a table in there, and I don't have it off of memory yet. I will. The reason I don't is I'm just, every time I memorize it, it changes it a little bit.
That is true.
And I want to make sure I remember it the right way. So there is a table that looks at the different ways or the different types of components, how they need to be inspected, and what technology. Right now, the way that it's written, if it's a gas processing plant, it would point to Appendix K. But
Okay.
some of the other ones may point to Quad OA, and they may change the quantity or the frequency in which it's regulated or inspected.
So, no, if I were to use your camera
Mm-hmm.
from a standpoint of where the training difference is, I know from a Method 21, most guys have their internal training,
Mm-hmm.
kind of go through their Method 21 basic training courses and then advanced courses. What are the differences between using the TVA as well as the camera?
Yeah.
Is there certain training you have to go through? Are there classes? What's out there?
So I can't speak directly to TVA, right? I've never worked for a TVA company and understand that, the service provider side. From my understanding, it is more internal. It's pretty basic, right? This is the way you use it. This is how you calibrate it on a daily basis, and this is how you actually inspect. The way a TVA works, if I'm looking at this microphone, I would need it anywhere there is a potential joint on this microphone, a connection point. I've got a 360 degree, and I have to be able to do that. There have been studies, one of them was by the EPA out in California, where they said if you miss the TVA reading, right, if the probe is off by 1 centimeter, think about how many centimeters are in a refinery and how much you have to do.
Wow.
But if you're off by 1 centimeter, you will miss 57% of the leaks completely.
Mind-boggling. That's
So if you think about, that's the way it works. But you asked about the training, and so they asked them to do this. I don't know whether those trainings require them to walk around with a ruler to ensure they're within 1 centimeter of that. But that's kind of what they're asking the optical gas imaging people to do with a daily quality assurance and a daily, follow you around, record 5 minutes every day to ensure that you're doing your job accurately.
Okay.
I understand the QA and I understand the training. You need to choose one or the other, in my opinion. So what we offer at FLIR, we offer the very first optical gas imaging training. It's an ISO certified organization called the Infrared Training Center. It's a separate entity, but it's a part of FLIR.
Okay.
And so we've probably trained, I don't know how many thousands of operators over the years on how to use optical gas imaging cameras. We train them on the theory, we train them on the operation, we train them on the components they look at. Appendix K does prescribe, I believe it's around 8 bullets of exactly what that training needs to entail, and we will adjust our trainings appropriately. And this is about a 3-day course, instructor-led. You can do it now virtual, or you can have, instructor-led either on your site. We can do an on-site training to a larger group if you have that with your organization, or we could do it, we do them regionally, right? We may have one in Houston, one in Denver, and have customers that are in the area stop by and come in and take that training. There are other ways to get trained, though. I worked with FLIR and with our training group probably for 3 years in building what we did is we worked with one of the leading oil and gas companies in the world.
Okay.
And we built a training module online, right? It's called the OGI Fundamentals Online Course, right? So we built this online fundamental course that's around 3 hours, but we built this at the time to try to meet realistically what Appendix K was going to ask for, even though we didn't know what Appendix K was going to ask for. The theory of it, the technical aspects of the technology, how the camera works, what you need to look at, a little bit about the regulations. We don't put that a lot in there. That may be on the operator side because those could change. But we actually have that online. We worked with one large oil and gas company. They got 5 more to join and audit the course.
Wow.
Including, as well as the EPA was able to audit the course. And then we produced that, and that's what we put out to the public today. So you could literally do it's about a half-a-day training at your own pace online for, I think it's $400 right now. And if you go to infraredtraining.com, this is our infrared training website, there's a variety of options. And we can even tailor some of these to meet your needs. If you would prefer to have an instructor-led 1-day course, we can do that for you and do that virtually and have an instructor at their home or at our corporate office standing there just like they're standing in front of you. Technology is great in more than one way.
So I can be a certified camera operator by going through this online course.
To my understanding, we're developing the course so that it would operate, so that would happen.
Oh,
right.
man.
So I will say that attending a course in person and having an instructor-led, being able to ask questions and having more theory and technology, it has its advantages. Some people just they want to be able to get the nuts and bolts of everything, and this will suffice. So we're trying to be able to meet all aspects. We still also don't know in Appendix K. One other thing, Appendix K, is it introduced the word senior camera operator.
Yes.
And so the senior camera operator, will they have to have a certification, or will they just need a certificate of completion? There's a big difference there, right? One, I'm certified by a person that what I'm doing. The other one, I completed a module-based course.
Okay. No, it's good. You bring up some good points, and we talked a little bit about the differences between monitoring with the OGI camera as well as the traditional Method 21. One of the questions I have in here, it brings out, does Method 21 give false positives due to the sources of nearby emissions?
Yeah, I mean, it can. From my understanding, yeah. I mean, if you were looking at stuff, we actually have videos of oil and gas companies at refineries that sent us a video of a valve that they repaired 3 times. It tagged. They were using a sniffer. And that was the valve that was leaking according to the sniffer, because that's where it just happened to be that all 3 times the wind was blowing in a direction that caused them to actually tag the wrong valve. They weren't that far apart. And in some cases, you may have a valve next to a flange, and the flange may not have to be inspected, but the valve does.
Yes.
And so you keep getting a reading. So they keep repairing this with a sniffer. So they walked out with the camera and said, oh my gosh, that's the wrong thing. We're fixing the wrong thing, and we've done it 3 times. And so this happens. You can get the false positives with respect to that. Again, the studies have been shown that optical gas imaging can be more time efficient to be able to inspect over time, or to be able to inspect multiple components in a much quicker fashion.
No, great answer to that one. Another question that just came in is visualization important when determining leak sources?
Visualization. I guess, I think one thing that might, what the question may be asking is understanding what's happening, right? The awareness, if you will, the situational awareness of what's happening on site. You may look at, as I just mentioned, a valve, or you have multiple flanges and A's leaking and B's not, or seeing exactly where it is that you want to be able to fix, right? I don't want to fix the wrong thing over and over. And that's one thing with the optical gas imaging camera. We're not just taking a reading, taking it as gospel, and walking away and going to the next component. Okay. We actually can do this. Now, we go back to dwell time, right? Dwell time for 2 seconds is just to see, is something changing in my seeing? If you see there's a leak, your dwell time is going to go up because you're going to want to make sure that you actually document it, that you figure out exactly where that's leaking, exactly what needs to be fixed appropriately. So your dwell time in that case may go from 2 on a leaking component from 2 to 10 seconds to make sure that you get it done right. But on the everyday, just to see is something leaking, the dwell time could be less. But the visualization piece, in my opinion, is really important. That when you start getting to the upstream world, that the visualization piece is a whole different piece of compliance, if you will, but as well as technology, because there's a lot of technologies out there that can detect emissions, but you don't know where they're coming from. Again, I call it the situational awareness of emissions. So maybe there's an emission on this city block. Maybe it's at this building. Maybe it's in this parking lot or on this car. But I need to know which tire's leaking, right? And so a lot of technology, satellites may be able to get it down to a well pad.
Okay.
An airplane may be able to get it down to a tank battery, a tank, somewhere on that tank's leaking. You still have to go out and visualize what's happening with a technology that can point exactly to what's leaking, and to be able to point exactly what's leaking and know exactly what to fix or if you need to fix it. Because there are a lot of times, Matt, that it's not a leak. It's a vent, and these are operational.
Good
they
answer,
have vents in this business to save lives, right? You don't want a tank to blow it. You don't want something to have a higher pressure that causes something bad to happen. So that's the other thing with visualization with an optical gas imaging camera. We can not only visualize where it's coming from, but we can actually help visualize what's happening and is it supposed to happen.
Man, no, that's great. And you brought up a really good point, too, when you brought up the dwell time. I mean, the 2 seconds is a minimum. Mm-hmm. You can actually, to really get a good reading, there is no maximum.
Correct.
You can stay as long as you need to determine the proper leak source and where to get maintenance, because that's all important. I mean, nowadays, most facilities run very lean when it comes to their maintenance crews. So making sure you have the right point identified, where the leak's coming from, gets them there, make it more efficient for them to repair it, and move on to the next process in a timely fashion. So those are great, man. A few more questions I have here for you. How has quantification impacted the adoption of OGI?
So the quantification in OGI is much newer, right? So for many, many years, right, when the first camera came out, we got 2 big questions. Okay. Right? The biggest 2 questions we got for the first 5 to 10 years of optical gas imaging. Can it speciate, right? Can it tell me what leak it is? And to this day, we still, it's again, all of these gases fundamentally cover each other up, right? They're all over and they're covering each other in the absorption spectral range that they have. The other one is, can it tell me how much? And that was always a challenge to answer because we would always say no, right? We qualify, we do the hard part. Yes. Right, we find the leak.
Find it.
If you want to quantify it, you can bag it, you can high flow it, you can TVA it. But we're doing the hard part. We're finding the needle in the haystack. Now you can go see whether or not that needle is iron, silver, or gold. Right. But now we actually have the capabilities in working with a partner who is also a exhibitor at the 4C conference in Providence Photonics.
Great deal,
We've been working with them almost since the inception of optical gas imaging, very soon after. And one of the foundational pillars that we're working with Providence Photonics on is the quantification algorithms that we apply to the QL320 technology through our cameras that would either in a previously recorded video or actually directly in the field on the tablet itself, would actually allow that operator to immediately or post-process, but to take a video and quantify those emissions right there. So it's still new to the world. It's not a part of U.S. regulation. The QL 320 is approved and part of both Canada and Mexico regulations.
Interesting.
So as far as compliance outside of these borders, there is an aspect of quantification, or QOGI, quantification of optical gas imaging. There is an aspect of that tied to compliance, just not in the U.S. federal or even state regulations. So it is, Providence launched really the first one in 2016. We partnered with them much closer in 2017, launched a FLIR branded version with a minority share investment in Providence in early 2020. So now we're going on about 3 years of that, and we're continually looking at this technology and trying to make it better, trying to make it read better, and also just trying to make it easier to use. And we're continually working on that within our technology. One of the other challenges with quantifying is that with a sniffer, I just trust.
That's
right?
it. You're right.
I point, I get a number, and I walk away. But with an OGI camera, it's showing me what I'm looking at, right? The visualization piece. And if you look at it, you never see an OGI video, an optical gas imaging video, where it just has it looks like a pencil moving across, right? It's not just a steady stream. It's natural. It's natural fluctuations because of wind and movement and dispersion of a gas. It's turbulence, right? The gas is moving at different angles and at different things. So it is continually changing. And our numbers with that, if you just sat there and had it look, it is continually changing. It's like saying, what's somebody's heartbeat? Well, you average over time. You don't say what the rhythm is in microseconds. And so as we look at that, that has been where we've been working on getting that. And now the technology, you just take a reading and it spits a number out. Yeah, it spits a number at you and allows you that capability. So again, we're working to make that technology better. What is unique about ours in working with Providence is they have multiple consortiums. The Alberta Methane Field Challenge. We've done some testing at METEC in Colorado State. Concawe, which is over in Europe.
Wow.
We've done studies on the technology and how it compares to things like a sniffer or to things like a high flow sampler over an extended study or an aggregate reading.
So with you guys both being at the conference in April, will we be able to see the instruments work together? Will you be able to give a demonstration on that?
Of course, yeah. We're always up to show people the technology and show them what we've got and we're, again, as I said, we're working to advance the technology, make it better and easier to use all the time. And so, whatever, with the newest that we have available at the 4C conference, we're going to be more than excited. You can either stop by the FLIR or the Providence booth. We'll both be super excited to talk to you about it.
We can stop by both of them, right?
Why not?
Why not stop by both, man? I know we keep going, but we're so excited about 2023's conference, man. We have a lot of great things coming. Your technology is super stoked about it. Let me ask you this question. If I'm an environmental manager or a guy at a facility and I have the option between being able to use the OGI technology or Method 21, and I were to give you a call and say, hey Craig, I'm kind of in this quandary, I choose one or the other, what would you tell me? How would you help me make my decision?
Well, Matt, my opinion's a bit biased. I'll say that up front, right? So I can, what I would rather answer that versus my thoughts is what do my customers tell me? The ones that take a history of TVAs and literally a 30-year lineage of using this and say, we would rather do OGI. Now, the challenge that is out there right now is some of I call it the handcuffs of the AWP. As an example, when you walk around with a TVA, they trust that you're trained and that you're using it. Again, I don't have to walk around with a ruler to ensure I'm within that centimeter I talked about. I don't have to time how much I walk around, how much I scan, right? If I have a 12-inch in diameter component, I don't have to time, I don't believe, how much time I need to go scan around that. Does that take 1 minute or 20 seconds? How much time am I doing that? And with OGI, they're kind of putting some of those stipulations, in particular, again, following around with an OGI camera. With the AWP, they require you to record every step. If you're walking from component A to component B or section A of your refinery, zone A, whatever you call it, right? You've got to record every step that you make utilizing your LDAR program that day. And that is a bit cumbersome. And when this started in 2008, that was really cumbersome because that's a lot of data. It's a lot of data to record. And so that began to be a bit more of a challenge to some of the operators would say, well, I have to do this. The other thing is they said, well, by the way, we really don't want to trust this OGI technology yet, like they did in 2016 with Upstream. We're going to say you still need to use your sniffer once a quarter. And one quarter per year, right? So 1 out of the 4 times you have to do. Most of these facilities you have to do 4 inspections or quarterly inspections. So for 1 quarter you have to do this. Well, this means that operator has to have twice the amount of equipment, right? So they actually have to have a large array of sniffers, and they have to have people trained for both of them. So those are just a couple of the challenges that they have. But I usually point them to the customers that tell me, I get my job done faster. I can utilize this for components that are not required under regulation, that are DTMs. The biggest challenge that we see in the refinery world is that they still have to utilize the other technologies. So some of them say, you know what, I don't want to train twice. I just want to stick with one. Upstream, it's different, right? BSER, the best system of emission reduction, is defined as an OGI camera. So when you start getting in the upstream world, they just use OGI, to my knowledge. I don't know of many, if any, that would, because downstream you use method 21, and an alternative work practice you can use OGI with the restrictions. Upstream, it's recommended that they say the best system to use is OGI. The replacement, if you will, the alternative technology to use is method 21. To my knowledge, I don't know of, again, I'm biased in my opinion. The people don't call me and say, can I buy a TVA? To my knowledge, I don't know of anybody that is utilizing dual technologies unless they feel as though they want they want a concentration reading directly of what they're having, and that's very rare.
No, it's very interesting you bring that out, because some of the things I know, being a provider, one of the big issues a lot of the midstream and upstream guys were dealing with were MOC programs, which is really, really tough when you have a traditional.
What's MOC? There may be people listening.
Management of change.
Okay.
Anytime you add a piece of equipment, remove a piece of equipment, there's a management of change that must be in place.
Correct.
But when you're doing traditional method 21, a lot of times if you're not in the loop with that management of change, you don't know to go get that component, bring it in the database, or to monitor it.
Yeah.
Whereas when you have the camera, you're kind of scanning and monitoring everything within eyesight, so you capture those.
It doesn't matter if it's a valve or a flange or whatever, as long as I can see. That's why one thing with Appendix K or utilizing an OGI camera, we've always taught it, is look at 2 angles, right? I always tell people, don't ever assume that you don't have a leak. Try to prove that you don't have a leak.
God,
right?
That's a great
so
thought
when you're doing this, I want to look at something, and the dwell time is 2 times, right? It's at 2 separate angles. Okay. So the reason they're doing that is, like I've always told my users, try to prove to yourself there isn't a leak, and assume that everything's leaking. Because if you do it, if you go into that mindset and you look at these multiple, it doesn't matter whether it's a valve or if it's a flange. I'm going to look at 2 separate angles as long as I can see the parts or the seals or the areas of that might leak. Then I can inspect that component if I have an MOC, right? If I have something new, maybe I've never looked at it. I don't even know maybe where it's leaking. If I can inspect it and see it visually, then the OGI camera is going to tell you if there's a leak there.
Oh, very, very interesting. When you mentioned earlier that you had a partner when it came to quantifying the leaks. Do you have any partners that you deal with directly when it comes to managing the data? Because you spoke about, there's a vast amount of data when recording some of these things. Do you do that yourself? Do you offer that service? Do you work with other companies when it comes to managing the data?
Yeah. So what's unique about our partnership with Providence is that we do have a corporate MSI with them, a minority share investment in the organization. They were, we saw what they did, and it was the pillars that they stand on within their organization were very much in alignment with what we saw optical gas imaging, both at that time as well as for 10 or 20 years to go. And so with that partnership, it is more unique, right? It's actually a part ownership of the organization. Outside of that, we have a lot of partners when it comes to what I would call LDAR software, right? The third-party leak detection and repair software management. I don't know who all is currently exhibiting in 2023. I haven't looked at the list, but I can guarantee you there's going to be at least a handful of LDAR third-party software companies. Some of them may even be sponsors of the organization. We've given co-presentations at times with people. We've talked about how they take the data. We understand our core competency. Our core competency is making this camera and making the best optical gas imaging camera out there, leveraging our quantification team and our engineering team at Providence to ensure that not only we make the best camera, we make it measure as accurately as anything in the market and as easily as anything in the market. One thing that we have stepped back a little bit from is the reporting side, and one reason for that is if I look at one component on one side of the road or one facility on one side of the road in, let's just say, Colorado, and then on the other side, well, this facility might be state reg, this one might be federal reg, or this one's might be BLM and this one's EPA, and it's very challenging for us to have that in-depth knowledge of compliance on a state. If you go to Dallas, right, the city of Grand Prairie has their own regulations. I want to say Tarrant County does. I know TCEQ does, and the EPA. But you may run into a handful of components nearby that have different regulations. One of them requires quarterly, the other one semi-annually, and how do you go about ensuring that? So we've stepped away to be able to provide an all-encompassing, but because our cameras just store a standard movie, just an unproprietary movie file, you can do whatever you want with that. You can take that, put it into any type of software for doing that. The way that the cameras store sequentially, give you the capability to say, it's file 1, then file 2, then file 3. So some of these third-party companies can easily go out there and develop that and use their core competency, right? These guys are good at managing data.
I agree.
And that's just not it is something that we do, and we've got some softwares, but man, it really, Matt, it gets complicated when you start talking about regulation per component, when to reinspect, all of those things.
Good. So I see you brought a camera with you here.
Oh, yeah.
Craig, why don't you kind of show the camera to the camera, I guess, and tell us a little bit about this one. It's intrinsically safe. Give us some details on it.
Yeah, so this one is it is our Class 1 Division 2 or Zone 2 if we're talking in out in Europe or the rest of the world, if you will. So it is hazardous location compliant and certified in a Zone 2 or Class 1 Div 2. I don't like to say intrinsically safe definition because that's a company designation.
Okay.
Right? One company on one side of the road may say, to us, intrinsically safe is Zone 1. On the other side of the road, they would say to us, intrinsically safe is Zone 2. Or it may be, it's intrinsically safe in this area in Zone 1, this area in Zone 2. So rather than do that, ours is Class 1 Div 2, right? It is a hazardous location compliant camera, Class 1 Division 2. This is our flagship camera, the GFX 320. This is, the baseline model of, it is, Zone 1 or Class 1 Div 2. It is ATEX rated now. But the reality is it's built around a foundation of the same technology we've had for many years, right? One thing that hasn't changed a lot is the engine or the technology. It does exactly what it needs to do, and we've come out with the uncooled, but the uncooled doesn't meet the U.S. EPA regulatory. It's because it only sees methane, and a lot of these times these gases aren't just methane, and so. Have that, this is going to allow you to store, images on an SD card, unproprietary. You can actually, there's a feature in here called Q mode, where I can actually record a video file. I take the camera, put it on a tripod. The reason I have to do a tripod with quantification, because as I mentioned, we're watching that leak as it's moving, right?
Okay.
So we're looking at the distance that it moves, how far away I am from the camera, and then the camera does a lot of the rest of the work. And so I can actually record a video in an ATEX environment and then post-process it on our QL320 after the fact. And so, it is extremely easy to use, and it allows you to do this in areas where a lot of times you may not be able to do it. Don't have to carry around a secondary tablet. I can post-process that, so it makes it easy.
So if I were to go out and purchase this or call you, what all I need to be able to go out and do my job? Does it come with the camera?
Mm-hmm.
Do I need special lenses? Do you have somebody who can kind of walk me through what lenses I'll need based on what I'm looking for?
Yeah, well, luckily I've got an amazing sales team globally that can help walk you through those, answer those questions. This one specifically, when we did our ATEX rating, it has a singular lens, right? So you have a lens, and to take the lens off and back on would not allow it to meet ATEX ratings the way that this is manufactured.
Okay.
So you have the camera, the lens. We provide you everything you need: camera, batteries, the SD card, lens cap, the neck strap. All of these things we're going to provide you directly. Carrying case, all of those things make it simple. The only additional thing that is pretty common, or a couple of the additional things that would be common. One is quantification, right? Okay. The way that the technology is, do you want to quantify or not? Quantification is a technology that's not driven. Even though it's not a requirement per se, right? A lot of people say, well, FLIR is just because it's required. No, quantification is not required. And there are a lot of companies out there that want to meet their ESG metrics, right? Yes. They want to be able to tell their investors, I not only am stopping emissions, I'm stopping them at this level, and this is how many emissions I've stopped in 2022. And sometimes the CEO has his bonus goal is tied to emission metrics at some of these companies, right? So, additional to the camera itself, a quantification tablet with the QL320, which again, any of our sales staff can discuss that very easily. And then the training, again, we as an organization provide a wide variety of training, right? We provide the instructor-led in person, instructor-led virtual, online if that's what you prefer. So that wide variety of training to be able to do your job there. But now there's not a whole lot outside of that. It's a pretty simple. And then again, as I mentioned, a lot of times for the data management, you can manage the data however you want, right? Okay. You could do it on an Excel spreadsheet or a pad of paper in a spiral. But a lot of these data management companies that we do, kind of talk to them, partner with them. I talk to them a lot on the technology and the camera and how to ensure that they can get the technology out of the camera appropriately to put into their solution.
No, you know what, Craig, this has been amazing. A lot of great information for us to take in and digest a little bit, and I'm sure all our listeners really thank you a lot for some of the details you've given us about the camera. But I want to have a little fun now, if you don't mind. The conference is, less than 90 days away. And you and I, we've done a lot of conferences, a lot of them together. We've seen one another. So I know you're not only exhibiting, but you're also speaking several times at the conference. You're moderating the track for us. So you're very, very heavily involved with the 4C conference. But a lot of times when you get to a conference and I'm an attendee looking at things, I really don't get to know Craig. So tell us a little bit about Craig. So we go up to you at the conference, at your exhibit, or after you speak. What do we know about Craig?
Yeah, no, I appreciate you asking, right? You get into that business mode and you guys like to put some presentations together. And sometimes I got to get off stage pretty quickly, which is great, right? The conference itself is just jam-packed with the most vital information. It's even as an exhibitor, I learned so much going to the 4C, and I have for many, many years, and that's one thing I love about it. But as far as me, I've been with FLIR for over 20 years. I've been directly.
Man.
I started with FLIR in 2002. I didn't know what infrared was, it's kind of one of those. A headhunter comes to you and says, "Hey, there might be a job," but no, I've been with FLIR for 20 plus years, and it has been a fun job because, especially when I sold everything, not just optical gas imaging. But even with optical gas imaging, I can do the same thing 3 times a day, or a different thing 3 times a day. I can go one day and walk into here, into a electronics manufacturing facility with infrared. The next day I'm at an oil and gas facility looking with optical gas imaging. Then I'm visiting a fire department. So we have such a diverse, so it's been a fun 20 years. But personally, I've got a beautiful wife at home, two little boys that
Awesome.
that are really the light of my life. And sometimes they test my patience, like anybody that's got two little boys 2 years apart, 7 and 9 years old. So,
oh man, beautiful.
They literally fill me with joy. A little puppy dog that they let me take a part in. And personally, I've grown up loving sports. Right, I am a Cowboys fan, and I know
all right, there we go, buddy. All righty.
I know the 4C is a strong Cowboys fan. So
we back America's team.
Yeah, of course. You've got to do it. You got to do it. We'll got to see what happens in the Super Bowl. So. But now, Cowboys fan, and grew up loving sports, basketball, huge golfer. And if you can't find me on a deer lease with my kids, I'm probably on a golf course.
I hear you're pretty much that golf shark they tell us about around there, man.
I don't know if I go quite with the golf shark, but some of my friends may. It depends on the day. Let's just say I get every way. I have my day every now and then.
So you a TCU guy?
No, I went to Texas A&M.
A&M guy.
Yeah,
okay, gig him there.
Yeah, I graduated from Texas A&M and with an industrial distribution degree.
Okay.
Which is I would imagine if you were to pull that poll or survey of how many people at the 4C conference that went to A&M have that degree, you'd find a fair amount of those exhibitors may raise their hand. Yeah, so it was a great degree. It's a kind of half engineering, half business degree, with the engineering side directly to industrial distribution. Graduated from A&M and just I've loved the Aggie network, friends. They've been the ones standing by me in my wedding, and the ones taking my money on the golf course when they think they can.
No, this has been a great pleasure, Craig. Thank you so much for spending time with us and being our first guest on our first podcast.
I'm excited.
We're really great about that, man. And
I hope you have me back. And who knows? We may have some exciting stuff at FLIR in the near future.
Wow.
Maybe even something to share at the 4C, and maybe next time I come, I can have a cup of tea. What do you think?
Hey, I think that's a deal, man, and we're looking forward. We will definitely have you back, Craig.
Yeah,
we love that aspect of it. Again, it's our first podcast, Spilling the Tea with 4C. Yeah. Thank you, everybody, for joining us, and we look forward to having you back, brother.
Matt, I got to say, welcome aboard. I mean, I've worked with you since you've been aboard, even though you've kind of been behind the scenes now. But man, what a pleasure it's been to I knew you as a co-exhibitor.
Yes, sir.
Right? We were always trying to steal the 4C time, and now I'm trying to take yours as a 4C guy. But it's been great, Matt, working with you and the last what has it been? A couple months now?
Yes, since September.
Yeah. So you've done a heck of a job hitting the ground running, and man, I look forward to many years in the future.
Hey, thank you, Craig. Thank you very much for the kind words.
Yep.